Welcome to this eye-opening exploration of the hidden side of our shift to green energy. We're all excited about electric cars and renewable power, but did you know that this clean future might be creating new problems on the ground? We're swapping air pollution from cars for polluted lands from mining batteries. The push for electric everything is using up rare minerals too fast, and much of the battery waste can't even be recycled yet. It's time to ask, are we just moving the pollution from the sky to the soil? Let's dive in and uncover the truth with simple facts everyone can understand. The Lithium Paradox. Imagine shiny new electric cars zooming down the streets. They look so clean and modern, but behind that pretty picture is a harsh reality in places like South America's Lithium Triangle, which includes Chile, Argentina, and Bolivia. This area holds over half of the world's lithium, a key ingredient in batteries. To get lithium, companies use huge open-pit mines and pump salty water from underground. This process uses up to 500,000 gallons of water for every ton of lithium. That's like filling 750 swimming pools. In these dry desert areas, this massive water use is hurting local plants, animals, and even flamingos that live in the salty lakes. Indigenous communities who have lived there for generations are losing their water rights and seeing their lands change forever. For example, in Chile's Salar de Atacama, the ground is sinking by up to 2 centimeters a year because of mining, and groundwater has dropped over 10 meters in the last 15 years. We're basically borrowing from the earth now, creating a debt in the soil instead of the sky, all because we need more and more minerals without thinking about the long-term damage. The toxic afterlife. Now, think about what happens when those batteries wear out. By 2026, millions of early electric car batteries are reaching the end of their life, but our recycling systems aren't ready. Only about 5% of lithium-ion batteries are recycled today, leaving a huge pile of waste. In landfills, these zombie batteries can overheat and start fires that are hard to put out, releasing toxic fumes. Even worse, heavy metals like cobalt and nickel can leak into the ground and poison water sources. Recycling is tough because it's often cheaper to mine new materials than to recover old ones. Mining costs less due to low labor and regulations in some places. This creates a straight-line waste problem instead of a circle where materials get reused. Experts predict by 2032, we'll have up to 200 million electric vehicles on the road, meaning even more batteries heading to landfills if we don't fix this soon. The human and mineral price tag. The story gets even tougher when we look at where other battery minerals come from. Cobalt and nickel, vital for batteries, often come from places like the Democratic Republic of Congo, which supplies over 70% of the world's cobalt. There, mining can involve child labor, up to 40,000 kids working in dangerous conditions for just $2.50 a day. Workers face unsafe tunnels, low pay, and health risks from dust and chemicals. Geopolitically, this creates tensions as countries fight over control of these resources. We're also hitting peak minerals, meaning the easy-to-get, high-quality deposits are running out. Projections for 2026 show we'll need way more cobalt and nickel than we can sustainably mine, exhausting supplies at current rates. Our green goals in wealthy nations are linked to exploitation in poorer ones. Kids mining cobalt so we can drive electric cars. It's a hidden human cost we can't ignore. Invisible infrastructure impacts. Batteries don't just appear. Making them takes huge amounts of energy, often from coal-fired plants in countries like China, where most production happens. Producing one electric car battery can use as much electricity as a household does in a year, and if that's from coal, it adds a big carbon footprint before the car even drives. Then, to charge all these electric vehicles, we need new high-voltage power lines, cutting through forests and wilderness areas, destroying habitats for animals. Giant battery factories are popping up, carving into protected lands and using vast resources. The zero-emission label for EVs sounds great, but when you add up the full life cycle from mining to manufacturing to grid upgrades, the total environmental disruption is more than just no tailpipe smoke. Studies show life cycle emissions for EVs are still lower than gas cars, but the hidden impacts on land and energy use are real problems we need to solve. A truly circular future. But there's hope. New technologies like sodium-ion batteries are emerging, using common salt instead of rare lithium, reducing the need for destructive mining. Solid-state batteries promise safer, longer-lasting power with fewer rare earths. To cut demand, we can shift from everyone owning a car to better public transport like buses and trains, and redesign cities for walking and biking. Laws are coming too. The EU requires battery passports by 2027, tracking every battery's life cycle to ensure recycling and ethical sourcing. Closed-loop manufacturing, where old batteries become new ones, could stop the waste cycle. If we act now with smarter tech and policies, we won't trade one environmental mess for another. We can build a truly sustainable future. Thank you for watching. Let's think twice about our green choices and push for real solutions. Like, subscribe, and share to spread the word.